Alright, welcome back to my YouTube channel, Massa Tutorials. Please do all to subscribe to this channel. Alright, so now we are coming to treat binomial theorem. Binomial theorem. So we have binomial. So when we talk of binomial is an expression. It's an expression which contains two terms. It contains two terms connected by a plus or minus sign. So this is termed as what? A binomial. Bi means two, right? So a binomial is an expression which contains two terms connected by a plus or minus sign. So this is the definition for a binomial. Or when you talk of a binomial expansion, you get that. So binomial is an expression which contains two terms. It contains only two terms connected by what? A plus or minus what? Sign. Alright, so let's see examples of binomials. Examples of binomials. So we have x minus y is a binomial. We have x plus 2y is also a binomial. We have 2a plus b is a binomial. We have x squared minus 3y is also a binomial. We have a plus 3b is also a binomial, so etc. So these are binomials. These are what? Examples of what? Binomials. So as you can see, we have only two terms separated by this operational sign here, which is what? The minus. So 1, 2. So the expression inside the bracket, there are only what? Two terms. So this one is termed as what? A binomial. Likewise, this one, x plus 2y, we have what? A binomial. Then 2a plus b, we also have what? A binomial. Then x squared minus 3y, we also have what? A binomial. A plus 3b, we also have what? A binomial. Then etc. So these are examples of binomial. As I already said, what? Binomial is an expression which contains two terms connected by what? A plus or minus sign. Then I'm giving you examples of binomials. So you can generate some examples yourself. Then take note of that. When it's connected by what? A plus or minus sign, you get what? Binomial, right? Okay. So now we are moving on to the next subtopic. I've done the introduction for binomials. So we are moving on to the next subtopic, which is what? The Pascal's triangle. 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 So let's see something here. I believe you all recall the time we were in basic school, right? Yeah, we did something like this. If you can recall, we did something as this. Then we have something as this. So as you can see, I'm building what? A triangle, right? So I can start with 1, then here how many? 3, then here we have 3, 2, 1, so I have 5, then we have 3, we have 4, 3 which is 7, then 8, 9, then 10, then it moves, right? So this one is a what? It's a triangle. So this one we are called what? Triangular what? Numbers. Triangular numbers. Triangular numbers. They are what? The triangular what? Numbers. Basic level, we did what? Triangular numbers. So we have 1 orange here, we have 3 oranges here, forming what? A triangle. Then also we have what? 5 oranges here, forming another triangle. Then we have what? Another 10 oranges here, forming what? Another triangle, right? So when you go to the market or when you visit the market, you can see this, right? You can see how they've arranged either the tomatoes, the tasty tom, then things. So you can see this. They are called what? The triangular numbers. So we can develop the triangular numbers. Now let's see the difference between them. So now here we have the difference here is what? 2. Then here the difference here is what? 3, right? Sorry. The difference here is 2. Then now here the difference here 1, 2, 3, 4, 5, 6. Oh sorry. Here it's supposed to be 6. So that here the difference will be 3. Then here the difference here will be 4, right? So you can see the next one. The difference will be what? 5, right? Are you getting what we are doing here? Now let's count. We have 1 orange. That's 1 orange. 3 oranges. We have 1, 2, 3, 4, 5, 6. 6 oranges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 oranges. And I said let's look for what? The difference, right? So when we subtract 1 from 3, we get what? 2. 3 from 6, we get what? 3. Then 6 from 10, we get what? 4. Then now, we want to generate the next 10. After 10, what will be the next 10? So now, let's see. We have the difference. So when we add 5 to 10, we get what? 15. So when we subtract 10 from 15, we get what? 5. Then now, what will be the difference again? Because we can see 2, 3, 4, 5, then here will be what? 6. So when you add 6 to 15, you get what? 21. I believe you understand that. So the next difference will be what? 7. And when you add 7 to 21, you get what? 28. So these are what? The triangular what? Numbers. How to generate the triangular numbers. Now, I want to recall you so that we can use this idea to develop what? The Pascal's what? Triangle. You want to use this idea, this analogy to develop what? The Pascal's what? Triangle. So now let's see. How can we develop the Pascal's triangle? So we are starting. Pascal's triangle. The Pascal's triangle. So we start with what? Binomial. Here will be binomial. We have our binomial here. Binomial. We have our expansion here. Expansion. Then we have our coefficients here. We have our coefficients here. So now, we have binomial, expansion, coefficient. I believe you know what a binomial is. I said it's an what? It's an expression, right? It's an expression with what? 2 terms connected by what? Plus or minus sign. So we can start. Binomial. Binomial. So if I have binomial, let's say x plus y to the power, let's say 0. Right. So let's see. This one is a binomial. So if I tell you to expand this binomial here, x plus y to the power 0, we all know that a to the power 0 is what? 1. A to the power 0 is what? 1. From this idea, we use it what? Here. So x plus y to the power 0. So the expansion here, when you're expanding this, we get what? 1. Because the whole of this x plus y, let's denote the whole of this x plus y equals a. So let x plus y equals a. So in place of x plus y, I can say that a will be equal to what? 0. And a equals 0 is what? 1. Do you understand that? And what's the coefficient here? The coefficient is still what? 1. Still. I believe you understand that. The coefficient is still what? 1. Let's develop. Still, we have our next one, what? X plus y to the power what? 1. X plus y to the power 1. Let's expand this one. If we have x plus y to the power 1, it's the same thing as what? X plus y. So the same thing as x plus y. When we expand, right? So we get what? X plus y. It's the same thing. So it means that this one is affecting the bracket, right? And it's appearing only what? 1, right? Only 1. So we have x plus y. And let's see the coefficient. Now what's the coefficient of this x here? Is what? 1. So 1. Then what's the coefficient of this x here? We have another what? 1. So this is it. So we have 1, 1. That's the coefficient, right? And this is the expansion for this binomial here. Alright, so let's see the next one. That's x plus y to the power 2. X plus y to the power 2. So now, how do we expand this? So we can just take your time. Here, you can say that x plus y to the power 2. This 2 is affecting the bracket, right? It means that this bracket is appearing how many times? 2 consecutive times. So we can get x plus y, another x plus y. Right. And also, this x multiplies the whole of this expression inside the second bracket. And also, this y multiplies the expression x plus y inside the second bracket again. So we have this x multiplying x plus y, then plus y being multiplied by what? X plus y. So we can say that x times x gives what? X squared. Then we have what? Xy. Then plus y times x gives what? Xy again. Then y times y gives what? Plus what? Y squared. Right. So we have this. So y times y is from what? The laws of what? Indices. We state that what? If they have the same base and they are multiplying, we do add what? The exponents. Right. So now let's go. X squared plus, we have like times here, which is xy plus xy, which is what? 2xy, then plus my x squared here, then plus my y squared. So I have this. So this is the expansion. So I have x squared plus 2xy, then plus y squared. I believe we are all following here. So now, what will be the coefficient? So the coefficient, we have what? Let me clean this very well so that I make it very small. So I have 1, 1, 1. So the coefficient, we have 1. Then the coefficient of x squared here is what? 1. Then the coefficient of xy is what? 2. Then what's the coefficient of y squared? 1. As we can see, right? So we have this. So 1, 2, 1. I believe you can see how the pattern are moving. It's forming what? The triangle, right? You can see the numbers are forming what? The triangle. Alright, let's see the next one, which is x plus y to the power what? 3. X plus y to the power 3. How can we expand this x plus y to the power 3? Now, if you want to expand this, unless we know what x plus y to the power what? 2. Do you understand that? X plus y to the power 2, which has the expansion as x squared plus 2xy plus what? Y squared. So if we know x plus y to the power 2, which is the expansion of that, then it's left with what? X plus y. It's left with this expansion, which is to the power of 1. Because if you have x plus y to the power 2 times this x plus y to the power 1, since they have the same base and they are multiplying, you can add what? The powers or exponents, which is 2 plus 1, you get what? 3. So we get back to your what? To this what? Expansion here. So it means that x plus y all squared, you can use that, this expansion, then multiply it by what? 1 of that, which is x plus y. Alright, so this is what I'm saying. So if I have this, which is x plus y, then multiplied by x squared plus 2xy plus y squared. So it means that this x multiplies the whole of this expression inside the second bracket. Then this y multiplies the whole of this expression inside the second bracket again. So now I can get x times x squared, which is what? X cubed. Then x times 2xy, I'll get what? Plus 2x squared what? Y. Then also x times this y squared, I'll get what? Plus xy squared. Now we are done with the x. So we come to the y. So y times this x squared, I get still x squared y. Right. Then y times this 2xy, I get what? 2xy squared. Then plus y times this y squared, I get what? Y cubed. So now let's see whether we have like terms. Let's see whether we have like terms here. So I have x cubed, still my x cubed here. Then 2x squared y. Then here x squared y. Okay. So 2x squared y, then x squared y. So you can see x squared y, x squared y. This one is 2. The coefficient of x squared here is 2. The coefficient of x squared y here is what? 1. Here x squared y is 2. Here x squared y is what? 1. So we can add, which is what? 3. So I'll get plus 3x squared y. Then here xy squared, xy squared. So now x squared y squared, xy squared, the coefficient here is what? 2. Then xy squared, the coefficient here is what? 1. So I'll still get what? Plus 3xy squared. Then I have my plus y cubed. So now we can't do anything to the expressions again, or to the terms here again. You cannot add this to that because they are unlike terms, right? So now, what do? We have to list our expansion there, which is x cubed plus what? 3x squared y plus 3xy squared plus y cubed. Right, so this is the expansion for that. The binomial expansion for this is that. So now let's generate the coefficient for this. So the coefficient of x cubed is what? 1. So write 1. What's the coefficient of x squared y is what? 3. So we have 3. The coefficient of xy squared is what? 3. So we still write 3. The coefficient of y cubed is what? 1. So we have that. So now I believe you can see that. You can see that. Now, alright, let's generate the coefficient for x plus y to the power 4. Let's generate the coefficient. Now watch here. Here, this is how we generated the coefficient. Or this is how we generate the coefficient. Now here we have 0, 0, we assume, right? Or here is 0, 0. So 1 plus 0 gives what? 1. 1 plus 0 also gives what? 1. Right. Then here, let's assume we have 0 here. So 1 plus 0 gives what? 1. 1 plus 1 gives what? 2. 1 plus 0 gives what? 1. So we can see that always the first term starts with what? 1 and ends with what? 1. Always the first term starts with what? 1 and ends with what? 1. Then here let's see the coefficient for this. 1 plus 0 gives what? 1. 1 plus 2 gives what? 3. 2 plus 1 gives what? 3. 1 plus 0 gives what? 1. Right, so we can get the coefficient for that. Let's generate the coefficient for this binomial expansion, x plus y to the power 4. So now it becomes what? 1 plus 0 is what? 1. 1 plus 3 is what? 4. 3 plus 3 is what? 6. 3 plus 1 is what? 4. 1 plus 0 is what? 1. As we can see, the first term begins with what? 1 and ends with what? 1. So that's how we generate the coefficient. Now you can generate a coefficient for x plus y to the power 5. So now it will be what? 1 plus 0 is what? 1. 1 plus 4 is what? 5. 4 plus 6 is what? 10. 6 plus 4 is what? 10. 4 plus 1 is what? 5. Then 1 plus 0 is what? 1. So Pascal is a great mathematician. Because you can see the coefficients of that. You can see the coefficients of that for Pascal's triangle. So it's very simple, right? It's very simple to note. It's very simple. So if you want to generate the coefficient of 8, you have to know the coefficient of what? 7 before you can what? Generate that. Do you understand that? You have to know the coefficient of what? 7 before you can what? Generate what? That. Right. So they are very simple to do. So this one is the coefficient for x plus y to the power 5. We can generate the coefficient of what? X plus y to the power what? 6, which is 1 plus 0 gives what? 1. 1 plus 5 gives what? 6. 5 plus 10 gives what? 15. 10 plus 10 gives what? 20. 10 plus 5 gives what? 15. 5 plus 1 gives what? 6. 1 plus 0 gives what? 1. Always I said what? It begins with what? 1 and ends with what? 1. So they are the coefficients, right? So you have to know all these coefficients, how it is generated. You understand that? So if you want to get the coefficient of x plus y to the power 40, you have to get the coefficient of x plus y to the power what? 39 before you can get the coefficient of x plus y to the power what? 40. So it's very simple to do that. It's very simple to do that. Now, if you want to expand this, you know x plus y to the power 3. So you just multiply it by what? X plus y. Then you get the expansion for that. So it's like we use what we know to find what we don't know. We use what you know to find for what we don't know. Do you understand that? So you have to use what you know to find what you don't know, then it proceeds as that. Right? So very simple. Very simple. Also, you can find for the coefficient of x plus y to the power 7. To the power 7. It's good. To the power 7. So it moves as 1, then this one 7, then this one 21, then this one 35, then this one 35, then this one 21, then this one 7, then this one 1. So it ends with 1, it begins with 1, then ends with what? 1. As simple as that, right? So this is how we generate the Pascal's triangle. And we will use this Pascal's triangle, their coefficient, to expand this binomial theorem and see whether we'll get this. So I will not claim that. We'll use the coefficient to get this. We'll use the coefficient to get that. Do you understand that? You can use the coefficient to develop what? The expansion. The Pascal's coefficients here to get what? The expansion, right? By this time around, we use what? The expansion to get what? We use the expansion to get what? Their coefficient. By this time around, we go the other way around, which is we use the coefficient to get what? The expansion, right? Okay. So now, let's see. Let's see. Let me read something here. So we can see how the Pascal's triangle is forming what? A triangle, right? A beautiful triangle. Very, very beautiful triangle. Very, very beautiful triangle. So they said what? Note that each line starts and ends with what? 1. Note that what? Each line starts with 1 and also ends with what? 1. Alright. So it's very, very simple to do that. It's very, very simple to do that. So let's see. A Pascal's triangle gives an easy way of obtaining the coefficient for the binomial expansion. So that's what I'm saying here. That we'll use what? The coefficient to develop what? The binomial expansion. Alright. With small powers, but it is impractical for larger powers. So this one, we can use it for small powers like x plus y to the power 4. You can use the Pascal's triangle. But when I give you x plus y to the power, let's say 12 or 13, the coefficient will be, there are many to develop that. There are many. And it will be very, very tedious for you to do that, right? When I give you x plus y to the power 16, then I tell you to expand this. It will be very, very tedious for you. So that's how we are saying that we use the coefficient to develop what? We use the coefficient, the Pascal's triangle, to solve for small powers of this binomial expansion. Alright, not larger powers. If you want larger powers, you proceed, then you know how we use the larger powers for different thing else. We use another formula for larger powers. Alright. So now we are starting. Let's see. Now, but let's take note of something here. You watch this one, the binomial expansion, then coefficient. Watch it very, very carefully. I said when you are generating it, it's 1 plus 0, which is what? 1. 1 plus 0, which is what? 1. Then here 1 plus 0 gives you what? 1. 1 plus 1 gives you what? 2. 1 plus 0 gives you what? 1. Then here 1 plus 0 gives you what? 1. 1 plus 2 gives you what? 3. 2 plus 1, 3. 1 plus 0, 1. Also 1 plus 0, 1. 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4. 1 plus 0, 1. Then here we can get another one. 1 plus 0, 1. 1 plus 4, 5. 4 plus 6, 10. 6 plus 4, 10. 4 plus 1, 5. 1 plus 0, 1. So you can generate it yourself, right? It's very, very simple. Very, very simple. So watch it very carefully. All right, so let's see. Watch something here very carefully. Let's watch something here very carefully. Now, watch here. This one is the expansion. X squared plus 2xy plus y squared. This one is the expansion for x plus y to the power 2. That's the expansion for that, right? Now, x plus y all to the power 2. Now, watch here. This is what? X squared, right? Now, we have y here. X squared, we have y here, which is y is what? To the power 0. That's why we can't see y, because y to the power 0 is what? 1. So this y to the power 0 is gone. So that's why we don't write y, but there is y here. If you can see the y, this one is y exponent what? 0. Then here, plus 2xy. We have that. Then here we have x here, which is x exponent what? 0. Then y to the power 2. So watch here. Then mine plus 2xy. This x to the power 1. Then y to the power 1. We can see something here. Watch here. This is x plus y all to the power 2. So if I add this terms here, they are multiplying, right? If I add their powers, I have to get this binomial expansion, the power of that. Now, this 10 here, they are multiplying. If I add their powers, I have to get the same power here. So it means that 2 plus 0 gives what? 2. Then here, if I add their powers, x and y, that's 1 plus 1, I get 2. Then here again, here is plus. If I add this 0 to 2, so 0 plus 2, I have to get the same power here, which is what? 2. You can take any binomial expansion, just be adding the powers of the variable. You have to get the binomial expansion, the overall what? Power there. If you add, it must be equal to that power. If it is not equal to that power, then that means your expansion is wrong. So you have to check it very, very well. Always, if you add the powers, it must be equal to this 2. So as simple as that. As simple as that. All right. Watch here. I want us to use the Pascal's triangle to develop what? The expansion, or to find for the expansion of a binomial theorem. So I'm showing you some tricks you have to know. I said if you add the powers of the variables involved, you have to get this power, the same power, nothing more, nothing else. And also, watch here. They said, watch here. As x, this x is to the power what? 2. X to the power 2. Now let's come to this 10 here. The second 10. Watch x. X is to the power what? 1. Let's come to this 10 here. X. X is to the power what? 0. So you can see from this expansion that x is what? Decreasing. You can see from the expansion that what? X is what? Decreasing. Watch again. This one is x squared. But when you come here, it reduced what? X to the power what? 1. Then that means it is reducing by what? 1. Do you understand that? Alright. Now when you come here, x is to the power what? 0. It has reduced. So it means that x is what? Decreasing. When you move on to another term, x will decrease. The next term, x will also what? Decrease. Do you understand that? Now let's see. Let's see for y. Let's see for y. Now here y is to the power what? 0. Or y exponent what? 0. Right. So y exponent 0. Now when you come to the next term, it's y exponent what? 1. When you come to the next term again, it's y exponent what? 2. So we can see that y starts from what? 0. Then it increases to this what? 2. So we can state that y is what? Increasing. We can state that what? Y is increasing. Then here this x is what? Reducing. So x started from what? The highest power, which is what? 2. Then x reduced to what? 0. But here, y started from what? 0. That's the smallest power, 0. Then y increased to what? This highest power, which is what? 2. So this x will decrease, then this y will increase. So if you are using the Pascal's triangle, this is what we are going to do. So x will decrease, y will increase. So that's the arrow on top. X will decrease, y will increase. I believe you understand that. If x decreases, at the same time, y has to what? Go up. Decreasing, increasing. Decreasing, increasing. So that's what we can say here. Alright, so we've said that what? The coefficient form what? A pattern known as what? The Pascal's what? Triangle. Alright. Alright. So we are saying that again. What note here? Pascal's triangle method is used for expansion of the form. Is used for expansion of the form a plus x to the power n. Pascal's triangle. We can use this Pascal's triangle, their coefficients, to expand the binomial expansion here of the form a plus x to the power n for integer values of n less than what? 8. For integer values of n less than what? 8. So less than 8, I mean what? From 0 to what? 7. 0 to 7. Forget about the negative, right? Less than 8 from 0 to what? 7. So when it includes negative or this exponent, if it is negative, then we cannot use the Pascal's what? Triangle. We can use another what? Formula for that, right? Okay. So now we have that. So 0 to what? 7. So because when it turns out if the integer, this n, goes to 11, 12, 13, it will be very, very tedious for you to use the coefficient. You can use it though, but you will suffer a little bit. You can use it, but you will suffer a little bit. All right, so let's start and see. So now we understand the tricks here. All right, so we are using the Pascal's triangle to solve the following binomial expansions here. So we are starting. So we have, it said use Pascal's triangle to expand. It said use Pascal's triangle to expand a plus b to the power 5. It said we should use Pascal's triangle to expand a plus b to the power what? 5. Use Pascal's triangle to expand a plus b to the power what? 5. So solution here. We are using the Pascal's triangle. So it means that you use the coefficients of the Pascal's triangle to expand this binomial expression a plus b to the power what? 5. So now, let's see the coefficient. This one is x plus y, or a plus b to the power 0. This one is a plus b to the power 1. This one is a plus b to the power 2. So here we get 3. Then here we get what? 4. Then here we get what? 5. So a plus b to the power 5. These are what? The coefficients for a plus b to the power 5. So a plus b to the power 5. We have this coefficient to be used, right? So now we are starting. So we are using this coefficient 1, 5, 10, 10, 5, 1. We are using the coefficients again 1, 5, 10, 10, 5, 1 for the expansion. So let's start. So we are starting with this 1 times, so when you see this dot, it means I'm multiplying. So 1 times, that's the first coefficient. 1 times, I told you that this one will decrease, and this b will increase, right? This a is decreasing, and this b is increasing. So if this a is decreasing, then that means if you are decreasing something, then that means the thing is at what? The top or above, right? Then we are decreasing that, so it's from up to what? Down. So that means A will start from what? 5. Then times this B will increase, and this B, if it is increasing, it starts from what? 0, right? So B to the power 0. Then we add to this coefficient, which is what? 5. So we get 5 here. That's the second coefficient. 5 times this a. I told you that it is what? Decreasing. It started from 5, so it will decrease by what? 1. So we get what? 4, right? Then times this b. It started from 0. It is increasing, so it will move by 1. You add 1 to this 0, which is what? 1, right? Then plus the next coefficient, which is what? 10. So 10 times the same a. It is decreasing, so it will move to what? 3. So 3. Then times this b. It is what? Increasing, so it will be what? B to the power what? 2. Then plus we have the next coefficient, which is what? 10. So I have 10 times, we have this a is to the power 3. It is what? Decreasing, so it will be a to the power what? 2. Then times this b. It is what? Increasing, so it will move to what? 3, right? Plus again this 5 here. So 5 times what? A. A is what? Decreasing, so it will move to what? 1. Then times b is increasing, so it will move to what? 2. It will move to 4, sorry. It will move to 4, from 3 to what? 4. Then plus the next coefficient, which is what? 1. So 1 times a. A is decreasing, so it will move to what? 0, right? Then times b is increasing, so it will move to what? 5. So we can see the expansion. So let's simplify that. So we have 1 times a to the power 5 times b to the power what? 0. B to the power 0 is what? 1. Then 1 times this, we get what? A to the power what? 5. So we get our a to the power 5. Then plus 5 times a to the power 4 times b to the power 1. We get what? 5a to the power 4, then b. So there is no need to write this one. It's the same thing as that. Plus 10 times a to the power 3 times b to the power 2. We can write it as what? 10a cubed b what? Squared. Then plus 10a squared b what? Cubed. You can write it as what? 10a squared b cubed. Then plus we have 5a to the power 1 times b to the power 4. You can write it as what? 5a then b exponent 4. Because there is no need to write this one again. Plus 1 is multiplying that. A to the power 0 is what? 1. So we get 1 times 1 times b to the power 5, which is what? B to the power 5. So this is our expansion. So which is a to the power 5 plus 5a to the power 4b plus 10a cubed b squared plus another 10a squared b cubed plus we have what? 5a b4 then plus what? B to the power 5. So this is what? Our expansion for what? A plus 5, a plus b all to the power what? 5. A plus b all to the power what? 5. Very, very simple. Very, very simple. Very, very simple. Because I said that what? This first variable or the term inside this bracket here, it will what? Decrease. And the second term inside the bracket for this expression. So here, this one what? Will increase. So we start, because a is decreasing, you start from what? The highest power for this So if this one was 6, here was what? 6. But here is 5. So you start with what? 5, then 4, then 3, then 2, then 1, then 0. You can see that it is what? Decreasing by what? A unit, right? So 1, 1, 1. It will decrease by 1, 1, 1, 1. Then here B, it is increasing, but it will start from what? The smaller power or the smallest power, which is 0. So B to the power 0, then 1, then 2, then 3, then 4, then 5. So now, when you add these two variables, their exponents or their powers, it must be equal to this 5. So 5 plus 0, which is what? 5. 4 plus 1, which is what? 5. 3 plus 2, which is what? 5. 2 plus 3, which is what? 5. 1 plus 4, which is what? 5. Then here 0 plus 5, which is what? 5. So it means that my expansion is correct. Very, very true. It's very, very true. Alright, so you can watch. So now, let's see another one. Let's see another one. So I always tell you that I said for this Pascal's triangle, you have to take notes. When they give you the question, check the power. Is it more than 7? Is it to the power 12 or 13? Then you check before. Is the power positive or negative? So you have to check that, right? Because we say that what? The power, the exponent n, must ranges for, or it must be in a range of what? 0 to what? 7 before you can use the Pascal's triangle. Because when n is negative, it will be very, very difficult for you to use the Pascal's triangle. So now, let's start with another question. Z expand 2x minus 3y. We are still using the Pascal's triangle. 2x minus 3, 2x minus y to the power 3. 2x minus y to the power 3. 2x minus y to the power 3. We are using what? The Pascal's triangle. 2x minus y to the power 3. We are using the Pascal's triangle. The Pascal's triangle. So how can we expand this using the Pascal's triangle? So you can check. This is a positive what? Exponent. And it's affecting the bracket, right? Alright. So you first have to what? List the coefficients of this exponent 3. So you can see exponent 3, a plus b to the power 3. These are the coefficients for that, which is 1, 3, 3, 1. 1, 3, 3, 1. 1, 3, 3, 1. So that's the coefficient. Right. Okay. So we are starting. We write this 1, the coefficient, which is 1, times. There are two terms here, which is 2x minus y. There are two terms, which is 2x minus y. We have 2x, then we have minus y. Don't forget. So this one is decreasing. The whole of this 2x is decreasing. Then this minus y is what? Increasing. Right. Now this one, if it is confusing you, you can write this one as 2x plus this minus y all to the power 3. You can write this. You can write this one as 2x plus what? Minus y all to the power what? 3. So let's go. So 2x plus minus y all to the power 3. So now I said this one is decreasing, then this one